Hello everyone and welcome to the channel Science Roots. In this particular session we are going to discuss about the Kirchhoff's voltage law for DC circuits. In actual there are two methods by which we can use Kirchhoff's voltage law for simplifying the circuits or reducing the circuits or calculating the value of current flowing through a particular branch or a loop. So many of them are not aware about the matrix method. Here in this particular video we are going to mainly focus on the matrix method, but in the time being we are going to also understand the conventional method. So the sign convention that we are going to follow for the convention method is, for the rise in voltage we are going to take positive sign, for the fall in voltage we are going to consider the negative sign. If we go through a resistor in the same direction as the current, then there is a fall in potential because the current flows from higher to lower potential, and this voltage will be taken as negative. However, if the direction is opposite to that of the current, then there is a rise in voltage. Hence, in such case, the voltage rise will be taken as positive. So to understand it much more simpler way, I have considered one simple loop where we can see there is a loop named A, B, C, D, A. So the loop name is always starting with the first letter and ending with the same letter. So in this case we have A, B, C, D, A. Now the direction, now if there are two voltage sources actually, E1 and E2, where we can see the direction is taken in the upward direction. So if for the voltage source, if we are traveling in the upward direction, as per the sign convention this is positive, and if we are going in the upward direction, the direction of current is same. So if the tracing of path and the direction of current is same, then the direction would be taken as negative. So in this case, for the first branch, that is AB, the tracing of the path is from path A to B. In that case, the direction of current is the same direction as that of tracing the path. So we are going to take it as negative. Similarly, for the next branch BC, we have the tracing path from B to C. In that case, the current direction is I2. Again, the direction will be negative, that is minus I2 R3. For the next branch from C to D, the tracing of the path is from C to D. But now if we observe the direction of current, it is opposite to that of the tracing path. So in that case, we will take it as positive. Again, for the last branch D to A, if we are tracing the path from D to A, the direction of current is same. Again, it will be negative. So this is the direction for the current along with the resistance. But when we take for the voltage source, now here E2, we are traveling towards, for this particular branch B to C, the second polarity we have to observe. That means we are traveling from positive to negative side of the potential, so it is going to be minus E2. Similarly, when it comes to battery E1, we are traveling towards higher potential in the upward direction, so it is going to be positive. So this is the way how we consider the sign conventions. Or rearranging the equations, we get I1 R1 plus I2 R2 minus I3 R3 plus I4 R4 equal to E1 minus E2. So the first equation represents summation of all the EMFs or the voltage drop equal to 0, and the second equation is sum of IR equal to summation of E. Now let us consider an example where we have a circuit shown where we have the combination. Actually there are three voltage sources, 100 volt, 20 volt and 50 volt, followed by the combination of resistances, and we are asked to calculate the current in each branch. So let us take the current sign conventions or the direction of current in this particular manner. For first loop, A, B, H, G, H, A. So that represents the first loop. We are taking the clockwise direction of current. Second loop is represented as H, E, F, G, H. That represents the second loop. Again, the direction we have taken clockwise. The restriction is not there. We can take clockwise, we can go for anti-clockwise direction also. But in few cases, the result or the final answer of current might be in negative. No need to worry in such case. If the current is coming negative, only you reverse the direction, that will make the positive value of current. Similarly, for the third loop, we have B, C, D, E, H, B. That represents the third loop. So here we are taking three independent loops. We are not taking the repeated loops. Actually, there are 4 loops, but we are considering 3 loops. 4 to 5 loops, we are considering 3 loops. In such case, now we have to find the equations by using KVL. So the first loop, that is A, B, H, G, A. Sometimes this loop will be represented in some reference books or textbooks. They might refer mesh or loop. It is one and the same thing. So A, B, H, G, A. So we are considering this first part AB. We are having current I1 which is going in the same direction as the direction of tracing path. So it is minus 60 I1. Here we have two currents. One is I1 flowing in this direction and I2 flowing in this direction. So it will be minus 30 I1 minus I3. Similarly for 50, there are 50 ohm resistor. There are two currents I1 and I2. One is going downwards, other is going upwards. So it is minus 50 I1 minus I2, minus 20. Okay, we are going towards the negative side, that is the negative side of the potential, minus 20, and towards the positive side of the potential, plus 100 equal to 0. So rearranging these terms, dividing by 10, having the common factor of 10, we get this as the first equation. Similarly, applying for second loop. Now when we go for second loop, that is H, G, H, E, H, E, F, G. So in this case, we have now 20. This is the voltage. We are traveling actually towards the positive side of the battery. Then minus 50, traveling in the same direction, I2 minus I1. Minus 40, I2 minus I3. And here 10 is only one current, that is minus 10 I2, because the direction tracing the path and direction of the current is same. So it is going to be minus 10 I2. And we are traveling towards the positive potential of the battery. So it is plus 50. So from this, again, we will have the second equation. Again, common factor or divide by 10 to each term. I will get this as the second equation. Similarly, for the third loop, you can try on your own now, where you will get the third set of equations. So I'm having now 3 equations, 3 unknowns. 3 unknowns are I1, I2, I3. So you can see, you represent, or I have highlighted the 3 equations. So when you solve these 3 equations simultaneously, you will get the values of currents I1 1.65, I2 2.12, I3 as 1.5. So solving these 3 equations for the engineering students, you can go with the scientific calculators, 3 equations, 3 unknowns. If it is at basic level for 11th and 12th class, you can use substitution methods. You can first calculate the value of I1, eliminate any one variable, that is I3. Keep the equation in form of I1, I2, solve the equation simultaneously, calculate the value of current I1 and I2. So this is the way how you will get the 3 values of current I1 1.65, I2 2.12, I3 as 1.5. Now this is the conventional method. Now when we have a complicated circuit, this calculation becomes much more difficult as the number of current increases. So to avoid this, we are having one more important method, that is called as the matrix method. This is most interesting method, but there are few rules need to be implemented. The first rule is consider the independent loops. Independent loops, we have in the same example, we are having 4 to 6 loops, but we are taking independent loops. This is the first loop, second loop, and the third loop. Second rule is that direction of current in all the direction of currents in all the loop has to be same, either in clockwise or anti-clockwise direction. If for one loop you are taking clockwise and another 2 loops are you are taking anti-clockwise, it will not work for this particular method. So either you take all the loops in clockwise or all the loops in anti-clockwise direction. The third important rule is the diagonal elements should be positive and the off-diagonal element should be negative, or sometimes it is referred as non-diagonal elements. So here R11 to mean R11 is the first element, that is the diagonal element. Now here the diagonal elements, the suffix that is 1 1 1 2, 1 represents 1 1 represents first loop, 1 2 represents first and second loop, 1 3 represents first and third loop. So the suffix 1 2 and 3 represents the loop numbers. The fourth important rule is current in each loop I1, I2, I3 will be unknown, that we have to calculate the value. And the important additional rule, that this rule might be applicable for, not might be applicable for each and every example, it is only applicable for the voltage sources. If in one loop there are one or more than one voltage sources, so we have to follow the polarity conventions. If the sign convention, the battery sign conventions are opposite, then we are going to have the addition of voltages. If they are having the same kind sign conventions, then we are going to subtract the voltages. So this is the way how we implement the Ohm's law. If suppose we write V, now this is the standard equations where we are considering 3 loops as per the example that we have taken. If there are n number of loops, we are going to form this n number of matrix. So the number of loops will define the order of the matrix for this resistance matrix. So it will be n cross n, and it is always going to be a square matrix. Like for example that we have taken, we are having 3 loops, so we are going to have 3 by 3 matrix. For 2 independent loops, the matrix will be 2 by 2, and so on. So there are 3 voltage sources, V1, V2, V3, followed by resistance. As the rule we have taken, the diagonal elements will be taken as positive. So R11, R22, R33 will be positive, and the off diagonal or the non-diagonal elements will be negative. So minus R12, minus R13, minus R21, minus R23, minus R31, and minus R32. Now here one more important thing is that all the matrix elements are symmetric. That means whatever is the value of R12, it is same applicable to R21, R13 is same like R31, R23 is same like R32. Right? So after understanding this matrix method, the rules that are applicable, let us go to solving the example related to the matrix method. Now the same example that we have used for conventional method, we are going to consider for finding the current, loop currents I1, I2, I3, and we are going to compare the result with the conventional method. So this is going to be very interesting. Let us give the loop number. So I have given this as loop number 1, this as loop number 2, loop number 3. Now here there is no need for you every time to represent the equations or write the separate equations. So first what I'm going to do is, depending on the independent loops for 1, 2 and 3, I will first reframe the generalized equation, that is V1, V2, V3. I will write the resistance matrix and the current matrix that remains the unknown. Now let us understand. Now in the first loop, now this I have taken as the first loop. Now in first loop I have 2 resistances, sorry, the 2 voltage sources, one is 100 volt and 20 volt. Now if you observe, this negative polarity is connected to the negative polarity, 100 volt polarity, negative polarity is connected to 20 volt negative polarity. So the polarity is same, so we are going to have subtraction, that is 100 minus 20. So you can see here 100 minus 20, that is the first loop. Now in the second loop, we'll first find, or we are going to first form the voltage matrix. So the second element represents the second loop, that is V2 represents the second loop. Again, when we consider a second loop, we are having 2 equations, 2 voltage sources, one is 20 volt and another is 50 volt. Now if you observe clearly, 50 volt positive polarity is connected to 20 volt negative polarity, so it is going to be additive in nature, so 50 plus 20. Similarly, in the third loop, there is no voltage source, so you can observe here in the third loop there is no voltage source, so we are going to write directly as 0. So this is very important. If there is some absence of some voltage source, you are going to represent that value as 0. Now what does this R11 represent? So this R11 represents the summation of all the resistances in first loop. So in the first loop we have 60 ohm, we have 30 ohm and 50 ohm, so I have taken the summation of 60, 30 and 50. Now when I say loop number 1 and 2, R12, the resistance which is common to first and second loop is 50 ohms, so it is going to be minus 50. Similarly, 1 3 represents resistance which is common to first and third loop. So if you observe, for first and third loop the common resistance is 30. So here I will write it as minus 30, as the non-diagonal elements we are taking negative values. So R12 is similar like R21, so this is minus 50, R21 will be minus 50, R22 again summation of all the resistances in the second loop, summation of resistance in second loop we have 50 ohms plus 40 ohms plus 10 ohms, so I have represented 50 plus 40 plus 10. Similarly, we have the resistance R23 that is common to second and third loop, we have 40 ohms, so it is going to be minus 40. Again R31 is same like R13, so minus 30 it will be reflecting here. R32 is same like R23, minus 40. And similarly the resistances in the third loop, in the third loop we have 30 ohms plus 20 ohms plus 40 ohms. So 30 plus 20 plus 40, I1, I2, I3 remains the unknown. Now what I will do is I will just do simple addition subtraction. This is 100 minus 20 will give me 80, 50 plus 20 will give me 70, and the last element will be 0. So 60 plus 30 plus 50 will be 140. Other elements will be the same. 50 plus 40 plus 10 will give me 100. Again 30 plus 20 plus 40 will give me 90. So simple, what I am going to do, as each term I can divide, each element of the matrix I can divide by 10. So this 80 becomes now 8, 14 I1 minus 5 I2 minus 3 I3. Then I have 7 equal to minus 5 I1 plus 10 I2 minus 4 I3. Similarly 0 will be equal to minus 3 I1 minus 40 I2 plus 9 I3. So these equations are somewhat similar to that we have got in the previous equation, and solving these three equations simultaneously will give me the value of current I1 1.65 ampere, I2 2.12 ampere, and I3 1.15 ampere, which is similar to the conventional methods that we have got I1, I2 and I3 as 1.65, 2.12 and 1.5 ampere. So this method can be applicable for any number of loops. One more important point, if there is one more loop and the matrix becomes 4 by 4 matrix, for the first and fourth element, for the first loop and fourth loop, that is R14, there is nothing common, so you can represent that element as 0. So if no resistance is common between any of the two loops, we can take it by default as 0. Still you are going to get the results. In case if we get any negative value, as mentioned earlier, we are going to reverse the direction of the current. If it is clockwise, you can reverse to clockwise direction. So hope this video was helpful for you. Please let me know your suggestions or any feedback in the comment section. Thank you.